Okay, great.
Okay.
So, HPC workshop number 2. What we're covering tonight. What we're covering today. So this is going to be, hopefully there's going to be some good continuity between this workshop and last workshop. Last workshop was basically an introduction to the cluster and navigating your way around. Today, we're going to be talking about scheduling jobs using Slurm, our scheduler and resource manager. We'll take a deep dive into Slurm, looking at the essential Slurm commands that you're going to need to get your jobs running and to manage those jobs. We'll look at simple job submission scripts, take a look at job arrays. We'll have tips for submitting, pro tips, if you will, for submitting jobs. And then we'll sort of take a departure from job submissions and look at managing your environment using R and Python, how you can self-manage your environment and make sure that you have the packages available that you want to have without necessarily depending on the folks at HPC Help to install those packages for you. We're certainly happy to help you out whenever, however we can, but if you can self-manage your environment, you can work that much faster, and we're happy to help you get up and running doing that. And then lastly, we'll look at some simple shell scripting examples. The way you interact with a job scheduler is by submitting shell scripts. So the better you are at writing and managing your shell scripts, the better you'll be, the better, more effective you're going to be at writing job submission scripts. Excuse me. So, let's give you an overview of Slurm. Slurm is it's an acronym. It's also a fictitious soft drink. It stands for Simple Linux, Unix, and Resource Manager. A Simple Linux Utility and Resource Manager. Although it's somewhat of a misnomer because I think it's arguable whether it's simple or not. The nice thing about Slurm is that it is probably the dominant schedule and resource manager in HPC now everywhere you go. It's rapidly displacing other schedulers. Slurm requires no kernel modifications for its operation and is relatively self-contained. And as a cluster workload manager, Slurm has 3 key functions. Number 1, it allocates exclusive access to resources, i.e. compute nodes. That's not, in fact, this is location dependent, the fact that Slurm operates with the exclusivity flag set. What that basically means is this: when you submit a job and get a node or nodes, you won't be sharing those nodes with other users. That node is entirely yours to do with what you need. Second, it provides a framework for starting, executing, and monitoring work, normally a parallel job on a set of allocated nodes. So once a job begins, you can use Slurm to do such things as monitor the progress of the job, to send you alerts or warnings when the job changes state. You can and do other things. For example, look at your job submission history, and some of the more advanced features that we'll cover as the talk continues. And finally, it arbitrates contention for resources by managing a queue of pending work. What does that mean, actually? So what Slurm really does is, or you can think of it, it plays a multi-dimensional game of Tetris. I suspect most of you, or at least some of you, are familiar with this game, Tetris, where you have these blocks and you're trying to pack them as densely as you can into this grid. That's essentially what our scheduler does. But this multi-dimensional object is your job, and the dimensions are, for example, the number of nodes, the amount of time, and so on. And essentially, the scheduler tries to pack as densely as it can everyone's jobs so that we can have as high utilization as possible. And it does a pretty good job. You know, utilization fluctuates by season. It goes up when grants proposals are due, it tends to go down during the holiday breaks, but on average, it's probably, I think it's fair to say that on average, our utilization is somewhere around 85%, and at peak utilization, we're over 90%. So why use Slurm? Why use a scheduler in the first place? Slurm allows jobs to be scheduled so that a user doesn't have to wait for a node to become free for work to begin. And that's a really good thing. We have over 1,000 users currently on Colonial 1. And we don't have 1,000 nodes for those users to use. So essentially what one does is figure out what your job needs to run interactively, let's say, and then codes that into your job submission script. You'll provide such information as the number of nodes required, the sort of node configuration that's required. You'll tell Slurm where your working directory is, where your data are, where your scripts are, or your executables, and Slurm will manage the rest for you. And the best thing about it is that it does run in batch mode. So you can submit a job, 10 jobs, hundreds of jobs, thousands of jobs, if you will, and walk away, go on to do something else, and those jobs will be processed in order based on certain factors such as priority and node availability. And when you come back to the cluster, those jobs hopefully will be there, the results will be there waiting for you. Slurm allows resources to be prioritized for groups that purchase shares on Colonial 1. There should be somewhat of an asterisk, I think, at the end of this line because we're no longer selling nodes on Colonial 1. We're filled up. So this number, the number of shares that you have that can modulate your priority on the queuing system, at this point is frozen. Slurm enables efficient use of the cluster since it constantly monitors resources in use and schedules jobs on unallocated nodes, as it should. How does Slurm do what it do? How do you configure a job environment? Well, there are two ways that you can do this. You can do this interactively, which is really not our preferred way of doing it. That's not a very effective way to use the cluster. The other way, which is the more effective way, is to script everything that you need. And we're going to cover that in laborious and tedious detail today. A submit script calls your job to execute your calculations. So let's jump in. If you haven't logged into Colonial 1, I don't have a URL bar. Okay. Yeah, if you simply Google MOBA Xterm, if you're a Windows user, if you simply Google MOBA Xterm, follow the download link. I highly suggest you use the home edition. It's free unless you want to spend the money. Go to download, and there are two options for download. There's the portable version and there's the installer version. Doesn't matter to me which one you use. The portable version is a little bit simpler to install, and if you decide you don't like it, you can simply drag it to your trash and all trace of it will be deleted. So having said that, does everyone have an SSH client to get us started? Okay. So what we're going to do now is SSH into one of the login nodes. And the simplest way to do this is to simply type SSH, your net ID, which is the username, your username before the @ symbol in your email address. Mine happens to be MACLACH at login.colonial1.gw.edu. And actually that went a little bit quickly. You'll be prompted for your password. I have SSH key set up, so it just logs me in immediately. And you should see something like this, although I suspect most of you probably won't be seeing the Stegosaurus when you log in. The Stegosaurus, that's our friendly dinosaur reminder that if you see the Stegosaurus in the top hat, that means that you are currently over your quota, your soft quota. And we talked about soft quotas last time, right? Getting some heads nodding, yes, okay, that's great. Yeah, apparently the dinosaur is not happy that I'm using over 1 terabyte in my home directory. Okay, so here's Colonial 1. We're now logged in. Everybody logged in? You'll know that you're logged in, by the way, because you will see at the prompt, you'll see the host name of whatever login node you've been assigned. There are 3 login nodes, login 3, 4, and 5, which sort of brings up the question, whatever happened to login 1 and 2? That's a good question. Anyway, so when you log in, we use a round-robin approach to either assign you to login 3 or login 4. I happen to have login 3. All right, the first Slurm command that we're going to run is sinfo, right? When you log in, you want to know what is the current state of the cluster? How many jobs are being run? How many nodes are free? How many nodes are allocated? What is the current state of the cluster in terms of job utilization? So if we type sinfo, we're presented with a table, 6-column table, 5 meaningful columns and 1 other column. Those columns are partition, availability, time limit, nodes, state, and node list. The first column, partition, tells us all of the names of the physical partitions to which you can submit a job. The first partition that you see in the list is the default queue that we abbreviate def queue with the asterisk. Note that the asterisk following def queue is Slurm's way of telling us, the users, that that is the default queue. If you submit a job to Slurm and don't tell it anything about what job you want to, what partition you want to run on, Slurm will just throw you onto the default queue. It's also our largest partition. As we move over to the left, we see the column availability, time limit, nodes, state, and node list. The availability column, for most purposes, you can ignore it. It always says up. I've never seen the value change, so I'm not sure how much utility that column actually is. But the next meaningful column is time limit. Time limit here for the default queue is 14 days. So we read this, the format as days, hyphen, hours, colon, minutes, colon, seconds. What a 14-day time limit means is this. You can submit a job to the default queue for up to 14 days, but no longer. If you want, you can submit a job to the default queue for as little as a second if you wish. But you cannot submit a job that runs for longer than 14 days. There are no exceptions to this rule. If it turns out that for whatever reason your job looks like it's going to take 15 days to complete, and you send us an email and say, please, 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 can you extend my job? We can't do that for you. In fact, the reason we can't do it for you is that it's not fair to the next users who are waiting behind you patiently for their jobs to begin. Yeah. By the way, maybe this is a good point to mention. If it does appear that you're going to have to submit a job that's going to run for longer than 14 days, we have a great option for you. It's a checkpoint restarting system, which we're happy to talk to you about and help you incorporate into your workflow. What the checkpoint restarting system does is the following. At some particular cadence that you specify, be it every hour or every day or every 4 hours or what have you, the checkpoint system will take a snapshot of your currently running application. It'll look at the open files, it'll look at what connections are being made, it'll look at the current execution state, and it'll freeze that image. So that at some point, let's say, I don't know, let's say some curious act of nature happens and, I don't know, we lose power or some unforeseen event prevents your job from running. What you can do is go back to your latest checkpoint and restart your job from that checkpoint. So that's a great fail-safe fault tolerance measure that you can take, but also it allows us to make sure that our jobs fit within these 14-day blocks. The next column is the number of nodes. That's the number of nodes that happen to be in the particular partition. The next column after that is state. So state tells us what state a node happens to be in. A node could be allocated, which means that you or another user has that node and is running a job on it. A node could be idle, which means it's waiting for a job. Nothing is running on it and it's waiting for you to submit a job to it. There are a couple of other states that we can come across. I actually don't see any of those states here in this table. Those states are drain or draining. And those are administrative states. If for whatever reason we need to take a node out of rotation, we'll put it into the drain state. Although thankfully I don't see any nodes in that state right now. Taken together, nodes and states give us 2 bits of information, basically 2 states that a particular node in a partition can be in. And that explains why we see 2 rows here for a default queue. We see default queue in row 1 and default queue in row 2. And again, the reason that we see these 2 rows is that we have 125 nodes in the allocated state and 3 nodes in the default queue in the idle state. If, for example, we had a node that was in the drain state, we would see yet a 3rd row for default queue. All right. Lastly is node list. These happen to be the names of the nodes that are in some particular state. Out of the gate, you don't really need to worry too much about the name of the node that you're running on. In principle, for the most part, all of the nodes within the same partition have basically the same hardware configuration. So for your purposes, it shouldn't really matter what node you're running on. And since we use central file systems, we write once from one node, and all the data that's written from one node is immediately available and appears on all of the other nodes. Primarily where node name would become a matter of interest is if you run into a problem running and you want to tell us, by the way, I was running on, let's say, node 033, and for whatever reason I had some peculiar out-of-memory error. I don't think I should have gotten it. Maybe there's a DIM that's gone bad or something like that, and we can help and go and triage. Okay. There's see, do we want to mention the expansion partition, or should we just?
No, because it's not available to everybody.
Okay.
So a lot of people are going to have access to it.
Okay. Very well. A couple other things to mention, not necessarily about sinfo, but about the partitions that you see when you invoke the sinfo command. We've already talked about the default queue. That's a 14-day time limit. That's actually the queue that we started out with over 5 years ago. And it turned out that there are some users who actually had relatively small jobs, and they just wanted to get them on and get them off. And putting them on this sort of massive highway where we have these very large 14-day jobs made it sort of difficult for the scheduler to get these smaller jobs running in an expedient fashion. So we created the short queue. The short queue has a time limit of 2 days. In practical terms, you can sort of think of the short queue as the express lane in the grocery store, right? When you have 12 items or fewer or something like that, right? So if you have a relatively small job and you just want to get it on and off, you may have a better chance of getting it running quickly if you submit to the short queue, and that's why that exists. Moving down the list, we see that there are some partitions that are grouped by hardware configuration, or in particular, the amount of memory that each node in that partition will have on board. There are, as of this presentation, if I'm not mistaken, there are currently 8 nodes running on Colonial 1. That's 8. 7, 8, 9, 8. The number of nodes on Colonial 1 that have only 64 gigabytes of RAM. If you decide that, well, I know that I have a memory-bound calculation and I need well more than 64 gigabytes of memory, you can submit a job to the 128 gigabyte queue, and you're guaranteed that your node will have 128 gigabytes of RAM. If that's not enough, there are 8 nodes on Colonial 1 that have 256 gigabytes of RAM. If the 128 gigabyte RAM is not sufficient, if you're getting out of memory errors, we're going to suggest that you submit your job to the 256 gigabyte queue. Many of you don't see in your list the next row, which is our 2 terabyte memory node. The 2 terabyte memory node is not by default available to all of you. We only have one, and it's in high demand. The bar to entry, the bar to access the 2 terabyte node is low. You simply have to ask us. In over 5 years of running, we've never denied anyone use of the 2 terabyte node, but we don't immediately expose it to you. If you do need a node that has a lot of memory on board, shoot an email to HPC Help, explain to us your use case, and also explain, by the way, it looks like my project will wrap up in 3 months or 2 months or whatever it is, and at the end of this time, you can remove me from the 2 terabyte partition, and we'll go ahead and do that. Next up are the GPU nodes. So we have a GPU partition. We have a GPU partition where we turn memory error checking off. It turns out that if you turn error checking off, you can squeeze slightly more performance out of your GPUs. So you can submit to the no error checking queue if that's what you wish to do. There's also the IB GPU with no error checking, the all GPU, no error checking. Actually, we don't have an all GPU without error checking, it looks like. And then we have 2 debug nodes. We have a debug CPU node and a debug GPU node. If you don't care which one you get, you can simply submit a job to the debug node. Now, the important difference between the debug node and all of the other nodes is essentially the amount of time for which you can allocate it. You can only get a 4-hour allocation on one of the debug nodes. These nodes are meant for troubleshooting. They're meant to be doing quick tests, not for running production jobs. So that's why we have a limit on, such a short limit on the time limit for the debug nodes. And right, I think that about covers it for sinfo. Any questions about that so far? None? Okay, great. Oh, question from...
On the memory limits, do you recommend just running a job and seeing if you run into them before asking for a larger one? In
an ideal world, we don't live in an ideal world, but if we did, then you, maybe independently or working with us, would do a scaling study. So we'd run a relatively small job, see what the impact is on the resources, maybe double the size, quadruple the size, etc. And we run this a few times, and we get this sort of functional form that perhaps we can extrapolate to the full size of your job, right? This is a scaling study. So in an ideal world, we'd have a pretty good sense about how much RAM you would need in the first place, right? But of course, nothing always goes according to plan. I think what I would do, if I wasn't sure whether my job was memory bound or not, would probably submit to the default queue or the 128 gigabyte queue, simply for this reason. We have many, many more 128 gigabyte nodes than we do any of the other configurations, and the likelihood of your job beginning to run quickly is much better there. So you'll probably get your answer there, either thumbs up or thumbs down, a little bit faster, and from there I would figure out, okay, do I need to go to a larger node or what have you? And again, it's not something really one can predict a priori unless you do this sort of scaling study. And so to minimize the amount of time that you've invested, I would recommend that strategy.
So what's the difference between the GPU and AV GPU?
Oh, I think if I recall correctly, and there's a good chance that I don't, I believe the IV GPU is using the Ivy Bridge CPU, CPUs from Intel. And I don't recall what the architecture is for the other older ones. Yeah, I don't recall. Okay, other questions? No? Okay, so let's move on then. Moving on. So the next thing that we want to cover is queuing system. However, sometimes it's really handy to be able to get an allocation on a compute node. Maybe you just want to do a really quick test by hand, just make sure things are working properly. Why wouldn't you just do that on the login node? Well, you probably could, and maybe you'd even get away with it once or twice, especially if your job was relatively small. Especially if your job was relatively small. But I think we mentioned last time, no compute jobs should be run on the login nodes. Okay, great. So I won't belabor that point. So this salloc command will allow you to get an interactive allocation behind the login nodes on one of our many, many compute nodes. And so how would I use salloc? What I would do is the following. Because I'm going to be getting an interactive allocation, I don't want to submit an salloc command to be sitting at a hanging terminal waiting for a resource to become free. And that's not what I'm looking to do. So for example, as I look at sinfo, I see that there are a number of nodes that are idle. Let's see. Oh, look at this. We actually have 12 GPU no error checking nodes available. So let's say I'm going to try to get an allocation on one of these nodes. The simplest way to invoke salloc is doing the following. -T for the time limit. I always have to specify a time limit when I'm doing an allocation, whether it's interactive or a batch mode allocation. It's similar to reserving a room or booking a room at a hotel, right? what do they always ask you? Whether you want a king size or a double. But they ask you, how long are you staying? In other words, when can we push you out of the room and rent it again to somebody else? The scheduler wants to know the same thing. So let's see, our workshop is, let's see, if I ask for 120 minutes, I should be okay, right? This is actually the bare minimum that I need to request an interactive allocation. I invoke salloc with a time limit. I didn't specify what node I'm using, what partition I want to use. But knowing what we know, if I submit this, can you guess what partition will my job be assigned to? Right, the default queue, right? We've already gone over it, the one with the asterisk. Let's see if that'll work. The dangers of presenting live. So we're waiting for resources. Well, I don't want to do that. In fact, since I happen to know that there are many more nodes free on the GPU no error checking queue, I'm also going to specify the partition using -p. So, what have I done so far? salloc -t followed by some integer. That integer is interpolated as the number of minutes, so this is going to be 120 minutes. And I'm requesting an allocation on the GPU no error checking partition. Come on, Slurm. Let's go. Looks like there's a problem with the cluster. Come on now, there we go, finally. That's actually surprisingly slow. If there's a queue available, it's been my experience, I usually get it within seconds, not tens of seconds, but okay. So I've been granted a job allocation. Job allocation 3516116, so this tells us that, well, number one, we've run over 3.5 million jobs on the cluster so far, so that's pretty neat. But what can I do with this job allocation now? Because I'm still on the login node. Well, there are a couple of options that I have available to figure out what node I've been allocated, because I want to get into that node. The first thing I can do is type SQ, and you can just type SQ with no arguments, but I like to be a little bit more explicit about what I'm doing. So I'm going to specify SQ-U and then my username. And that's going to tell me what node or nodes I've been allocated. The other method that I could use, which is a little bit fancier, is there's a command. Well, actually, you know what? I'm going to hold off on that until we get to the srun slide. All right, so I look at what's been returned from the SQ command. Job ID, partition, the name of the job, user, the state, it's in the running state, so we abbreviate that with R. And it also tells me when I invoke the command, the job had been running for 56 seconds. If I run it again, now I see the job's been running for 1 minute and 41 seconds. It tells me the number of nodes that I've been allocated and the name of that node. That's what I need to know. So what I'm going to do now is this. I'm going to try, oh, I didn't pay attention. It was node 027. So I'm going to try to log into node 027. I'll do that by doing SSH node 027. For you, it's going to be different. If you've been following along, for you, it's going to be different, but I'm going to go ahead and hit enter. And now I have made it beyond login nodes, and now I am on one of the compute nodes. So if you made it this far, congratulations, everybody. All right, yes, give yourselves a hand, a round of applause. There's something else I want to point out too, actually. You don't need to follow this example, but there's something else I want to point out here. I'm going to back out of this connection to node 0027. And let's suppose I fat finger the address of the host name that I want to log into. So instead of 027, I type SSH node 026. Now that's a perfectly fine host name. We do have a node 26. It's there. One of you may even have an allocation on it right now. I'm going to try to log into it, and I'm going to get access denied. User me has no active jobs on node 026, and so it's not going to allow me in. The only way you can SSH into a compute node is to get an allocation on it first, whether it's an interactive allocation like we're talking about now, or one of the batch allocations that we're going to look at later. And this protects you, and this is also one of the safeguards that we use to make sure that we use node exclusivity. So that node belongs to you and only you. But that was no good. Let me go back to node 027. Here I am on node 027, mistyping simple commands. Obviously, here I am. I'm in my home directory. I have a very messy home directory, but fine. Just to prove the point, here's my home directory. And you can see that the same data on my home directory, the same view of my home directory I have in the login nodes, is the same view of my home directory, or every other directory for that matter, that I have on the compute nodes. Every node sees everything on every file system. Any questions about salloc? No questions. All right. Going once. Going twice. All right.
Actually, decided I'm done with that before my 120 minutes is up.
Yes. Okay.
Release it.
Yep. Question mark, or is that?
It was question,
okay.
how do I release it?
Great question. So before, you saw me exit out of the node, right? Well, something happened when I got this node allocation. That sort of, it was happened behind the scenes, right in front of your eyes, but you probably didn't notice. When you were given this job allocation, you were actually put into a new shell environment, and we're still in that environment. If we type exit a second time, I'm about to do that, you'll see that my job will then be relinquished. So if I type exit now, I have now given up my allocation, and node 027 is free for the next user to come along and use. So just by hitting exit or Control D, we'll relinquish that interactive job allocation. Okay. However, I'm going to try to go back and get that job allocation again, because there's one other thing I wanted to show you. And we're waiting patiently.
How about if I create my SSH?
How, if you do what now?
Yes.
Oh no, I didn't hear the entire question. I'm sorry.
I mean, if you tab another exit, then you are free that node, right? But if I lose my connection.
If you lose your connection, how long have you lost it for? A couple of seconds, or do you actually have a timeout signal sent? If you have a timeout signal sent, you will lose your interactive job allocation.
Oh.
I don't believe Screen or TMUX can save you from this, if I'm correct. Actually, that's a question mark. Any of the other HPC folks recall if TMUX can preserve an salloc session? I don't think it can. I would have to check to get back with you.
Actually, I think you can, but only up to your time.
Oh, well, yes,
Yeah.
certainly, but.
But I was using the T-Mux to zip up.
Do you want to try it? See if it works?
Right now, sure.
I'm
Okay.
sure I use the URXVT, but I don't know.
TMUX, you're saying?
I'm using the URXVT.
Oh, no, well, actually, we're talking about a terminal multiplexer, and I think you're talking about a terminal client.
Yes.
Does that
But TMUX
do
is,
terminal multiplexing?
I think it could.
Okay, well, okay, since we're here, we might as well have the conversation, right? So, actually, what I'd like to do is let me finish this slide and talk about srun, and then I'll mention TMUX. Excuse me, apologize for the cough. I'm getting over a cold here. Okay, so I showed you one way to figure out what node you've been allocated, and that's by typing SQ or SQ-U and then your username. Thusly, and I see that I've been granted an allocation on node 012 or node 12 at this point. There's another way that I could have, a more general way that I could have figured out what host I'm running on. In fact, Linux and Unix in general provides a command for you to ask the computer, what is your name? Of course, fortunately for us, that information is provided in the prompt, but it may not always be, or more importantly, you may need to use that hostname information in a script that you've written, right? So you can actually ask your computer to tell you what its hostname is by typing hostname, and it says, my name is login3.colonial1.gw.edu. It's the fully qualified domain name, right? What I'd like to do is figure out what the name of the node is that I've been allocated. And so we actually have a special command that will allow me to take hostname or whatever other command, launch it from the login node, but get it to run remotely on the compute node. And that command is srun. So if I prep this hostname with srun will check with Slurm to see if I have an allocation, says, okay, I do, and it'll dispatch that command on that node that I've been allocated. So let's go ahead and just give it a try. So what's happened here is now my hostname command has been run on the remote node, and the result has been returned and displayed to me locally on my login node. So this is another more general way that you could figure out what node you've been allocated. And why is it more general? Because you don't have to run srun with hostname. You could literally run any command, get that command to run on the remote host. Yeah, okay. More on srun later. Oh, I forgot one other important option too. Here I'm going to control D to relinquish that job allocation, or exit to relinquish that job allocation. This time I need to get a little bit greedy. I'd like to get a little bit greedy. Okay, here I'm going to get a little bit greedy. So I see that there are 10 nodes on the GPU partition that are free. So what I'm going to do now is I'm going to request all 10 of those nodes. And the way that I do that is, I'm going to do that quickly before anybody else beats me to it. Haha. We'll see if that works or not. So dash capital N followed by an integer means how many nodes you're requesting. So I'm requesting 10 nodes. Yes?
Are you asking for 10 nodes each at 120 minutes, or the 120 minutes distributed over the 10 nodes?
It's the former. So it's going to be 120 minutes for the entire set. It's not like the additive, cumulative sum of each. Yeah, that's right. What nodes did I get? Well, I can type srun hostname, and this now I'm executing hostname on all of the nodes. Notice that it's coming out of order. If I run this again, I should get a different order. Yeah, sure, exactly. So the first time the results came from node 14, 12, 18. The second time I'm getting results from 18, 15, 20. It's not, this srun, like most parallel computing, is non-deterministic. You don't get to choose when it runs. It runs when it runs. It finishes when it finishes. And you, as the developer or programmer, need to construct your jobs, your applications, such that it doesn't matter in which order these jobs run, which actually goes back to a question we were having earlier. Okay. salloc, like srun, have many options that you can use to configure your job allocations and your job environment. And we've only touched on a few of the basic ones to get you running. In fact, I could probably dedicate 45 minutes or an hour on the options alone, so I'm not going to drill that deeply. So let's say at this point, are there any questions that about what we've talked about with srun or salloc that I haven't covered yet? No, come on, there's got to be some questions. You can't have me up here believing I'm doing such a good job explaining that there's no questions. All right, well, let's move on then. Yeah, we've already talked about SQ. There's one option that's worth mentioning. It comes up quite a bit. Users can be very impatient. Not you all, actually, but some of our users can get pretty impatient. They want to know, when's my job going to begin? And oftentimes they actually have a legitimate point because they've been waiting for their job to run, well, it can become frustrating. Through years of observation, based on these millions of jobs that we've run, we've come up with a pretty good rule of thumb, and that's this. Your wait time for a job to begin is roughly equivalent to the amount of time you've requested. Now, if you only want to run a job for 10 minutes, the scheduler is not going to have a very difficult time finding a 10-minute window that it can slide your job into, particularly because our scheduler is enabled to do something called backfilling. Backfilling is, it's much easier to explain graphically, but I'll try to do this in words, right? What backfilling does is this. Imagine your game of Tetris, right? And I don't know, you haven't been playing very well, and you leave some sort of gaps. Well, what backfilling does is it allows a small job to be plugged into those gaps. So you sort of skip ahead of other jobs that are waiting for you in the queue, but it doesn't really penalize anybody else because that time window was going to be unutilized anyway, and there happens to be a job that can fit within it, so we'll go ahead and plug that job there. That's called backfilling. It helps users with relatively small jobs get them running quickly, and it also helps us make sure that the utilization stays as high as possible. But suppose that's not happening. Suppose you don't have a job that's eligible for backfilling, and you begin to wonder, when is my job going to run? There is an option using SQ to get an estimate, and I say that with an underline, italics, boldface, estimate for when your job is going to begin. It is not a contract. We make no guarantees, and if your job doesn't begin when it was estimated to begin, we will feel sorry along with you, but there's nothing we can do about it. We simply have to wait for the scheduler to churn through whatever jobs are ahead of yours. So in order to get this estimate, well, the first thing I need to do is submit a job that doesn't want to start. So yeah, maybe I should have waited until the SBatch portion to show you how this works. Let's try this. I'm going to try making an unreasonable request to SILOC. It's not Singo, it's sinfo. Okay, so let's see. All of the debug nodes I see happen to be allocated, right? I'm looking down here. All the debug nodes are allocated, so let me try to get a debug node. Cache G, 120 minutes, and it's going to be waiting. And I'm waiting, and I'm waiting. So I'm going to come back over here to my other window. Oh, and pro tip number 2, always have 2 terminals open. Okay, so yeah, it looks like I have one job allocation that's currently running on the GPU node. We know about that one. But I also have a job that's waiting to get queued up onto a debug node. And that happens to be job number 3516147. So I'm going to type SQ, and I'm going to introduce yet another option with SQ. So far we've looked at -u, which allows you to specify usernames. So for example, I could see when Jason's jobs are going to begin or when Marco's jobs are going to begin by specifying their username. But here, I'm going to specify the job ID using the -j flag. So -j, the name of the job, and I'm going to type -- start and make this a little bit bigger. And so now Slurm is estimating the following. By the way, our clock is set to Eastern Standard Time. So Slurm is estimating that my job is going to begin on December 7th, today, fortunately, at 5:21. Hopefully I won't be here when that happens. But that's when it's estimated to start. Some things can go wrong there, though. Namely, one of the most common things that can go wrong is a user who has higher priority on the system can come in and make a similar request, leveraging the same set of nodes that I've asked for, and it can jump the line in front of me. based on their height and priority. And if that's the case, well, Slurm doesn't know that that's going to happen in advance before that user with higher priority makes that request. So it thinks currently that's the best time for my job to begin. But if another job submission comes in with higher priority, it's going to bump me back. And this is one of the most common reasons why users will be looking at the start option. It'll say, you know what, my job should have started, but now I'm looking at start and saying my job's not going to begin until Saturday morning. What gives? And generally, it happens to be that a user with higher priority jumped the queue ahead of you. By the way, notice that when I killed my window that I had submitted my interactive allocation on the debug partition with, and it was waiting for it. When I killed that window, after a minute or two, after a second or two, Slurm noticed that terminal had been killed, and it also removed my job from the queue. So now if I go and look for that job, it doesn't exist. Okay, any questions about SQ, salloc, or sinfo, or any of the other things that we've talked about so far? Yes, sir.
So if you, from the login node, can use the command srun to run commands on your compute nodes, what's like the primary use case for SSHing directly to the compute node?
So the primary use case would be, and bear in mind that for the most part, if I were to look at the number of batch jobs compared to S-allocated, the S-alloc jobs is probably fewer than 1%. So that's not our primary use case anyway. But if it were the case, the reason that you would want to SSH interactively into a login node, into a compute node, would primarily be for testing or debugging purposes, or if you just want to do a quick one-off by hand to make sure something is going to run, right? I have some big MPI job, let's say, and I just want to run a really small version, perhaps. Maybe look at it interactively. Okay. Actually, I'll give you an example. I'm going to go. I'll need another terminal here.
Well, I mean, the answer could just be this is just kind of for our gratification instead of, or like you said, a real use case.
Sure. Let's see. But actually, I do want to give you a real case that actually that almost certainly will come up. Oh no! Did I lose my allocation? Oh no, it's still there. All right. So let me go into, let's say, node 022. I don't know. Let's see. I could be running a job, let's say, on node 022. Of course, you can't really see that here because I have the font set pretty small. But let's say, I don't know. I'm running an application, and let's say, to make it simple, I'm running sleep. I want this session to go to sleep for 200 seconds. So, right. So then, why I might want to use SSH is the following. So while my job is running interactively or in batch mode, so for example, I could do node 022, I could run top to look at the process tables to see what processes I have running. I can see that I at least have two here. Sleep is actually really low down in the process table because it consumes basically no resources. I could do other things such on the node. I could type free if I wanted to. I could, basically start looking at diagnostics to see, is there something going wrong that maybe my job's not performing the way I wanted it to. On the other hand, if I have, if I'm back in the login node, right, and I type srun, if I type free, that's actually going to query all of the nodes for how much available free memory there is, right? So it really just comes down to a matter of preference, I guess, or what's most convenient for you. I guess psychologically, for me, it's more satisfying to actually get on the node itself and sort of poke around. But whatever works for you is, you have the option to go either route. Okay, other questions? Or comments? we'll open it up to discussion, right? Okay. Good stuff. Oh, and the -T option to list jobs by status. For completeness' sake, let's just go ahead and I'll show you everybody's job status. So by using the -T running argument, I can get a list of all running jobs. Or for example, I could get a list of all pending jobs. I wonder, can I also get a list of all failed jobs? Failed. Unfortunately, I have none because I don't submit jobs that fail.
What about a failed job? Where they stay in the queue?
Yeah, but what happens? No, it wouldn't be present. I mean, it's still there.
Yeah.
It's still there for accounting purposes, but it wouldn't be presented to you by default. It's not part of the default view of SQ. Okay, let's move on. The different states are, this is sort of the Rosetta Stone of the somewhat cryptic states that are returned by Slurm. CA is for canceled, CD for completed, CG, a job is in the process of completing, F for failed, node failure, pending, running, suspended, and timeout. Let's see, all right. All right, so the next two commands that we're going to look at are sbatch and scancel. Although in order to get in order to use sbatch, we have to create a submit script. So I might circle back here. We might go ahead and I think just create a submit script for ourselves, and then get some practice canceling our jobs if it needs to run us. So the commands we've looked at so far, just to make sure that we're all caught up in the same page here. Salloc, SQ. We're about to take a deep dive into scancel, sbatch, and of course we've looked at srun as well. Okay, let's actually roll our sleeves up and do a real a job submission. All of you at this point should have access, I believe that this is world readable. So what I'd like for you all to do is to execute the command that's been boldened here at the top of the slide. We're going to copy from C1/workshops/workshop2 hello.py into our home directory. So it's going to look like this. Copy C1 workshops2 hello.py. Actually, let's just do this. Let's do hello star.
Sure. Because you're going to copy the other one.
Yeah, yeah. So let's do this. It'll be maybe a little bit quicker. Now that's actually going to copy two files out of our workshop template directory into your home directory. Oh, and if this is unfamiliar to you, the tilde or the twiddle here is a shorthand, an alias for your home directory. So the first thing that we're going to look at is the payload, right? So we have to have a shell script to execute our job, but well, what is our job? In this case, our job is going to be a Python script. So let's just quickly open that Python script up and take a look at it. You don't need to do this with me, I'll do it for you. I'm going to use everybody's favorite editor, VI. If you get stuck in VI, raise your hand, and we'll help you get out of it. VI is actually very frustrating to get out of. Sometimes you feel like you have to reboot the cluster to get out of it. I assure you that's not the case. So here's our Python script. This is actually an MPI for Python script. Do we have any MPI programmers in the audience? Any MPI programmers in the house? Nobody's willing to admit to it? One brave soul is willing to admit to it. Oh, sure, yeah. OpenMPI is just one particular stack within an MPI framework, but that's great. Actually, that's my favorite stack also.
What's MPI stand for?
MPI is, MPI stands for Message Passing Interface. And it's one of the oldest frameworks, oldest libraries for doing parallel computing. It sort of gives away the game too. The name of the game in parallel computing is passing messages. And so this is precisely what MPI facilitates. So, just a quick word about MPI. What MPI does is it is a library, it's a standard, and so there are a number of MPI stacks, if you will, that are available for use. OpenMPI is one, Intel provides an MPI, MVAPICH, MPICH, and so on and so forth, right? Basically what MPI does is, I'll start an MPI job with, let's say, 4 Python instances. What MPI will do will spin up those 4 Python instances that are running precisely the same set of instructions. And you may ask yourself, well, what good is that? Why do I want to run 4 instances of precisely the same set of instructions? Well, among the many other things that MPI does, it also goes around and assigns every worker within the pool a unique ID, which by convention we call a rank. It begins at 0, 2, 3, 0, 1, 2, and 3 for 4 workers. And so then I can then modulate how my MPI scripts run based on what the rank is of a particular worker. I can tell rank 0 to pass a message to rank 12 and so on and so forth, right? It does a lot of other good stuff too. It's actually really a great framework to do parallel computing. But at any rate, so this is our Python script. It's very simple. I'm going to import the MPI for Python library as MPI. I'm going to set up a communicator object, which is, okay, well, for our purposes, it's not too important really what the communicator does. But the communicator is aware of what the individual processes' ranks are, and it's also aware of how many processes in general have been allocated. And those are the 2 lines that we have: rank, rank is equal to com.getRank, and size is equal to mpi.comworld.getSize. Okay. These 2 lines look a little different here, and I don't really want to go into a deep dive here, but by the way, the reason these 2 lines look a little bit different here is the full call would be MPI, which is an alias for the MPI for Pi library, .com_world.getSize, right? Well, com is just a shorthand, or in this case, an alias for MPI.com_world. So these lines really are the same thing, they just look a little bit different superficially. One gives us the rank, one gives us the size. And then lastly, we're asking, what is the name of the host that the process happens to be running on? And that's going to get stored in this host. Finally, what we're going to do is, this is not a super fancy MPI script. All we're going to do is print out what the rank is of a particular worker out of how many, what size the worker pool is, and what node it happens to be running on, right? That's our MPI job. Short and sweet, to the point, and hits all the essential features that we need for our first example. So if you are following along in VI, at this point, go ahead and hit escape, :Q, and get out of VI, hit escape, :Q, exclamation point, to mean that you really want to get out of VI, and you mean it this time. All right, so let's go ahead and take a look at our submit script. And oh boy, there's a lot going on here, right? So let's talk about what's going on. the very first line, which is partially obscured by my cursor here at the top. Anybody know what that line is called? Remember?
Oh, the shebang?
Awesome. That's great. That's fantastic. I was actually going to threaten you all with deducting points for lack of participation, but you saved us. So great. Yeah, that's the shebang line. For extra points, what does the shebang line do?
Oh, it's preprocessor command. Sorry.
I'll accept both of them. Yeah, that's right. So a shell script, it by itself, it doesn't know what interpreter is going to be used, right? Unless you want to invoke it, there's a way to invoke the interpreter along the command line. But the shell script by itself doesn't know what interpreter is being used. In this case, we're requesting that we use the bourne shell. We could have done something like using the K shell, the Z shell, C shell, bash, what have you. In this case, we're going to keep it simple and vanilla and stick with the bourne shell. The next 6 lines are Slurm directives. Slurm directives always begin with the first 7 columns. This is sort of like going back to like old school Fortran, right? The first 7 columns are dedicated. The first 7 columns have to be # S-bash, all capital letters. And it must be in this format. If I do this, that directive will be ignored. If I do this, the directive will be ignored. It must appear precisely character for character, exactly as you see it here. So # SBATCH. And again, reiterating what I mentioned earlier, there is one and only one Slurm directive that we require. All of the others are optional. The only Slurm directive that we do require is that you do specify the time limit that you're requesting, that you specify the amount of time that you're requesting for your job. How much time am I requesting here? Anybody? 5 minutes. Yep. Had I been in a rush? Oop. Had I been in a rush, I could have saved some time and I could have done that. That's perfectly fine. But yeah, say I want 5 minutes. Now here are a couple of other options which are new. SBatch-O testing %j.out. Well, what's going on in that line? As some of you probably already know, there are 3 common streams in Unix. There's standard out, standard error, and standard in. So I guess I'm looking here to see some recognition. So perhaps some of you may not be familiar with these different streams. If you are perhaps a C or C++ programmer, you probably are. What is standard out? The standard out stream is whenever you write something to standard out, the system, the operating system, is going to stream that data to whatever device is connected to standard out. And by default, the device that's connected to standard out is your terminal. So when you're writing to standard out, you're writing to the output of the terminal, right? If there's an error message, your operating system is going to be writing to the standard error stream. So these are 2 different streams that we can be catching signals into. And standard input, let's not worry about that right now. So what the first line is doing is the following. We're saying anything that would have been streamed to standard out, i.e. the terminal by default, I want you to catch it and store it in a file called testing %j.out. Now the %j is a variable. That variable gets interpolated by the job ID. So if my job number happens to be 123, I'll be storing the output, which normally would have gone to standard out, to testing 123.out. Now, there's also the standard error stream. And on the next line, what I'm doing is I'm catching any output that would have gone to standard error, which, by the way, by default, normally ends up on the terminal display also. That's going to go into a file called testing%j dot error. Now, there's nothing magical about the suffix out or error. It's just suggestive to a human being who's looking at this at the level of a directory with possibly many files in it, so you can quickly see what the error files and output files are. And there's nothing magical about testing, right? So, for example, I could have named these files, well, see, my name's Glenn, my middle name's Alan. I could have called it, Glenn%j.Allen, right? Or whatever. There's that. You can literally call them whatever you want. This is just a convention that we use here. Why would I want to do that in the first place? Unix has been around for the better part of 4 decades. Why do I need to go redirecting standard error and standard output? Well, the reason is that if you're using the system properly, hopefully your job is going to run at 4 o'clock in the morning while you're, in bed getting caught up on rest, right? You're not going to be there to see these error messages or these normal output messages that are being dumped out, right? You're not running interactively most of the time. So in order to archive these messages, we put them in these ASCII files, which will be available for you to look at later once your job is completed. On the next line, we're getting, I have a question from the back.
Hi, Claire. Can
Hi, Lynn.
can I ask more the S part? I call -n. No, can I do that?
Yeah, absolutely. Yep. Yeah, in fact, I'm gonna cover that in the next line right here.
Okay.
We're getting a little tricky here.
All right.
Getting a little tricky because what we're actually doing, in order to save space, we're actually doubling up SBatch directives on a single line. And so let's take a look at this. On this line here, we see the -P option, which we already saw before. What is that? What are we telling Slurm with the -P option, folks?
Which queue you want to use.
Exactly, yeah, which queue or which partition we want to use. So what this means is this. We have a comma-separated list. And so what this means is, try to run the job on the default queue or the debug queue. I think in general, in practice, I would probably frown on that sort of job submission, but because clearly we're sort of mixing context here, a production job and a debug job. But you can, for example, double up or triple up or what have you, add additional partitions by using a comma-separated list. On the same line, yes.
Are you not allowed to have a space after the comma?
Oh yeah, you can have space.
No.
Really?
Really? And the only reason I know that is because I typed that this morning. If there's a space, after the comma, SBatch will actually tell you right when you try and submit it that there's an error in your script. It interprets debug as its own command.
Oh, I wonder if it's interesting.
So yeah, comma separated list, no spaces though.
Because what it should do.
It's considered as another parameter if you add this.
Yeah, but what it should do actually is it should be looking for a hyphen, and the next parameter should begin with a hyphen as opposed to debug. I wonder if debug is a Slurm keyword. Maybe it's protected.
Oh, maybe.
What if you tried short? If it might.
I don't know. Actually, the only reason I have a debug is because somebody has put FQ up for like forever.
Oh yeah.
Yes.
Okay.
So none of these jobs are going to run if you don't include it.
Okay. So, yeah, what we're doing by doubling up here and using the -N on the same line is I'm requesting one single node here. Okay. Next 2 lines. These are dangerous lines, actually. So what's going on in the next 2 lines here? Actually, I'm going to cover these in reverse order. So it turns out that you can get Slurm to email you when your job changes state. Your job can be in the running state. Well, when your job is first submitted, it starts out in the pending state. Right? When your job changes from the pending state to the running state, when there's a state change, Slurm can be configured to email you, by the way, your job has started running. When your job changes state from the running state to either the completed state, hopefully, or the failed state, as happens from time to time, you can also get Slurm to email you then as well. If you don't care what condition you want to trigger an email line. If you just want an email, irrespective of what the state change is, we can say, we can use the keyword all to represent all state changes. So for example, here we have sbatch -- mail - type equals all, means no matter what state change occurs, if a state change happens, send me an email. And the email will go to the email address that's specified in the next line. Now, I really want to make sure that everyone's paying attention here. We talk about this in every workshop. We talk about it every time we onboard users, and somebody always makes me regret telling you about this.
Somebody's already doing it. 'Cause they're getting
I
cosmetics.
love it. Okay, great. Great. So, Colonial One will email anyone in the world. If you want to email the results of your job to President LeBlanc, or LeBlanc, President LeBlanc, you can do that. Don't do that though. He's a busy guy, and I'm sure he's happy that your research is going great, but he doesn't need to know like the minutiae of your job submissions. Be very careful about who you submit your emails to, because let's not make the rest of us look bad for allowing this feature. What one would do is make sure that the angle bracket, username, close angle bracket is completely replaced with your net ID. And again, I'm not going to put my net ID here because sometimes I found people are on autopilot and they put my net ID. I don't want to know about your jobs, the state changes either, so please leave my email address off this. In principle, you should be able to do a comma-separated list of multiple email addresses. At least that's what's reported in the Slurm documentation, but I have not found that to be a reliable feature. But the first email address in the list definitely will work. Okay. There are many more Slurm directives that we could issue in, there are many more Slurm directives that we could issue, but this is probably good to get us started. Any questions about those directives that I haven't covered so far?
I have one question.
Yes, sir.
On the line 1, 2, 3, 4, 5.
Here, let me, here you go. Pro tip number 3, set up line numbers in VI.
On the line number 6. So if I change the 1 to 2, will it add up 2 nodes?
Yes.
1 is important, 1 is bad.
I'm sorry. Oh,
Oh, actually, I think it's gonna, well, it's.
I hope not.
It won't split partitions.
I really hope it doesn't. But that's a good question, actually. That's something that I don't think has come up, at least in my experience. I'll tell you what, Jason's going to run a test here, and he's going to let you know in just a moment. The rest of our script is pure bash, pure Bourne shell, pure whatever shell you're in. This is pure, literally whatever commands you would have been entering at the command line, you can enter them within the script verbatim. It also supports, for example, the advanced bash features like arrays, iterators, for loops, while loops, etc. All the other features that make bash a fully functional programming language can all be embedded into our shell script. But we're going to keep it slightly simple here and just go with one-liners. Sure. Can I answer your question?
True if you put dash as the shell?
No, actually. However, if there are advanced features in Bash that don't appear in the Bourne shell, so if you want to get those advanced features, then we would just go ahead and do
Bash.
yeah. And if, you know, for example, if you were one of these guys, you could do that, or what have you. Whatever shell that we support, you can use with Slurm. If we don't have your favorite shell, shoot us an email and we can go ahead and install it. So, we talked about modules, right? Everybody's caught up with modules? Okay, all right, great. So, what we're going to do when we allocate, when we submit a job, is get that node with a fresh environment with a fresh environment with no modules loaded. Even if you loaded modules in your interactive environment, let's say, so for example, I'm going to exit this. Actually, no, I'm not. I'm just going to duck out real quick. Say I'm going to load. Hello, Wi-Fi. I'm not getting any love from the cluster right now. All right, so that concludes the workshop. All right, well, listen, while we wait for Colonial 1 to wake back up, I would check Ganglia and find out who's killing NFS, because that's almost certainly what's going on.
Lately it's on Splunk.
Oh.
Splunk is actually wrecking the CPU.
Okay, so while we wait for Colonial 1 to come back, let me make a couple of other remarks. The dash capital N that we saw in our submit script, the dash capital N in our submit script, what that does is allocates some integer number of nodes, right? So dash N capital 1 is going to give me one node on the, let's say, the default queue. Now, I happen to know that the default queue has, every node in the default queue has 16 physical processing elements, or 16 cores. When I request a node using the scheduler, using, let's say, dash capital N1, that's going to give me one node. I automatically have access to all of the system's resources. I automatically have access to all 16 cores, and I automatically have access to all of the system's memory. So I don't need to specify, give me one node plus 16 cores, or I don't need to specify, give me one node and let's say only half the cores, 8 cores. In fact, if you do ask for that, the Slurm will give you that allocation, but those other 8 cores that you didn't request are still available to you. Just bear that in mind. Whenever you get a node, all of the cores are available to you automatically. So how are we doing with the cluster?
You can get to login 5.
We can get to login 5. Have I mentioned login 5?
Our secret login.
It's our secret login node. Login 5? Why can't I spell? Login 5 used to be login 1. Okay, so yeah, sorry about the interruption, folks. If you have been locked out like I have, you can get yourself back in by doing this.
They're going to have to enter the username.
Oh, really? Oh.
Yeah.
All right. Oh. Yeah. Sorry about the interruption, folks. Did everybody get back into login 5? Just out of curiosity, do we know what's going on with the other nodes? Okay. All right, sounds good. Someone's working on it, so. All right. All right, so where were we? Yeah, I just mentioned that all the cores are available when you use dash capital N. Sorry, what's that, Jason?
I was going to say we were down to the module load commands.
Yeah. So when I get a job allocation, even if I have, oh yeah, here's what I was going to show you. All right, let's suppose, I don't know, we do module load, I don't know, think of something. Say I want to load MATLAB, right? So I currently have MATLAB loaded in my environment along with Slurm. The point is this: when I submit a job, it doesn't matter what I have currently loaded in my interactive shell. When I when I start this job, I have to explicitly name all the modules that I want to load within my script, right? This is part of preparing my environment. So in this case, what I'm going to do is I'm going to load two things. I'm going to load OpenMPI with a very specific version of MPI. 1.8 compiled with GCC, GCC version 4.9.2, and this is specifically tailored to the CPU nodes. The other module that I want to load is Python 2.7.6. Once those two modules are loaded, I'm going to go on to the third line, and I'm going to execute my Python for MPI script. I'm going to invoke that using MPI run. What MPI run will do, it will launch, in this case, 8 processes, 8 Python processes of hello.py. Why will I get 8? Because I'm specifying, I'm telling MPI run to launch 8 processes here. That's that. Actually, I'm going to put my username in here just to make sure that an email actually gets sent. All right, so the moment we've all been waiting for. We are going to submit our first job here as a team. So drum roll, please. The way one submits a job, once we've got our shell script created, is the following. We're going to do, I actually do have a drum roll, awesome. SBatch, and then the name of the...
Oh, it's hello_submit.
Oh, yeah, okay. Ta-da! SQ. The job's probably going to be done by the time I fat fingering out. Yeah, it's already done. And lo and behold, I actually have my output and my error file. In an ideal world, and we've already established we're not living in one of those, in an ideal world, my testing .err file would have 0 bytes of size. However, it turns out that not everything that appears in standard error is actually an error. So let's go ahead and open up our .err file and see what's going on there. First thing I'm going to do is let's use cat testing.
I don't know if it should be. Oh, because you left my.
Duh, what's my problem?
Because you can't read my home directory.
Yeah, that's right. Well, so the error stream actually works. Good news. Nothing useful here in .out. So let's go ahead and fix that. Hello.py. Is that where the problem is?
No, it's in the submit script. It should be the last line.
Last line of submit script.
Get rid of my net ID.
What a joker.
If my net ID happens to be in there, or the word net ID, put your own home directory in there. Yeah, or do it like that.
How many cores? Actually, I want to make sure I run on I'd like to make sure I run on a partition that's currently... Okay, so I do have some that are free right now. The default queue. I only want to make sure that I'm running on the default queue, so I'm actually going to get rid of debug here.
Okay.
Okay. How many cores are on the in the default queue? I already mentioned this. No, that's memory. How many physical processing elements do we have in the default queue?
I think there's like 300K.
I wish. There's 16. 16 cores per node. 16 cores per node. I'm currently asking for 8 cores. Well, let's just go ahead and run it like this. Yeah, it looks like it's done already. It's fast enough. Great. Now this is how now we're really rolling here. Notice how my .air file has 0 size, no errors. That's what I like to see. So let's go ahead and open up this file, our testing 351.61.73.out file, and take a look at our payload. And indeed, this is the result that we expect. I could change this to 16 cores and run a process on every single core. What about this? Will this work? There's 16 cores, but I'm submitting 32 processes. Will this work? It actually will work. But the problem is it will. In fact, I could go crazy with it. I could request 3,200 processes. You can oversubscribe your processes to these cores, to these processing elements. But if you oversubscribe them, we're HPC users. Our cores are busy 100% of the time, all the time. If we start oversubscribing our processes so that there are more processes than there are physical cores, we're actually going to inhibit, we're going to hurt our performance. So it's a good idea. Make sure that the number of processes that you instantiate is less than or equal to the number of physical cores on your system, on the node. So I would not do this. Oh, in this case, though, our job is actually not really compute intensive, so it won't matter much. Okay. Okay. How are we doing on time, by the way? Where are we? 4:10. Okay. Questions, comments, complaints. Questions, you can refer to me. Complaints, you can go to Jason. Actually, it looks like about half the class is still heads down, so I'll give you a minute or two to catch up. How do the other login nodes, are they coming back up? Anybody?
I mean, login 5's alright. Login 3 loading's down there trying to login 4. I mean, login 4 is still working.
Okay. Are we good? Do we move on? So the next topic we're going to talk about is a slightly more advanced topic in Slurm, and that's job arrays. There are a number of ways that you can submit more than one job at once. There are some of the... Oh, I think I might have skipped scancel. I apologize. I'm going to rewind. I want to mention scancel. I want to circle back and talk about scancel and then come back to job arrays. You don't need to follow along with what I'm about to do, but I'm going to make a real quick edit here to Yeah, okay, actually, that's,
Let it hang around for a while.
yep. I meant to request, let's say, 10 nodes, but I accidentally requested 100 nodes, right? And I'm like, oh no, I'm sort of panicking here. I have a job that's in the queue and I don't want it to run. So what I can do is, I have a couple of jobs here that are in the queue. And let's say I want to get rid of, this was a mistake. I didn't mean to submit this. I'm going to use, the last Slurm command that we're going to take a look at today is scancel. And that's going to allow me to, as the name suggests, cancel a job which is currently pending or running in the queue. There are a number of ways that I can invoke scancel, but the two most common ways are, well, the most frequent way is simply doing scancel and then followed by the job ID. And that is going to remove that job ID. If in one fell swoop, I wanted to remove all of my jobs, let's say, I would do something like, actually, just leave it like this. I can invoke scancel with the -u and then the net ID, and then what this will do, this will kill all of my jobs within the queue. Although it's far more likely that you'll be using scancel like this, like more a targeted approach, right, as opposed to just go ahead and killing all the jobs. In fact, I think probably it's the admins that probably get more use out of this invocation than the users do. And now I have no more jobs. Mark, have you gotten an email recently?
A lot.
Okay. Okay. All right. Back to job arrays. So there are a number of ways that you can actually submit more than one job at a time. Before the days of job arrays, what one would do is use a job submission script and then use some sort of iterator, like a for loop or a while loop within your shell script. And remember, I mean, this is a shell script, so all of the advanced programming features that shell languages normally support are supported within the Slurm script as well. However, that's not really ideal. If for no other reason, then it actually makes the accounting terribly messy by basically looping over some loop and submitting multiple tasks. There's another way to do this. And the first thing I should probably mention is the maximum number of jobs currently that Slurm will hold in the queue is 100,000. So you could, for example, submit 100,000 jobs all at once. And Slurm would be happy with that. We wouldn't be happy with it because we have other users submitting jobs as well, and so if we exceed that number, Slurm actually goes into a state where it doesn't accept any more jobs, and so it starts reducing the number of active jobs that it has in the queue. So that's our current hard limit. At least it's the default for our local installation. 100,000 jobs at any particular time. You can submit a job array, and a job array can have up to 1,000 elements within that array. And so think of a job array as simply that, as an array of jobs. Every element within that array represents another job, right? Job arrays work the same as every other job. They're indexed slightly differently, as we'll see in a few moments, but for the most part, everything else works the same way. If you can sort of think of it as syntactically similar, but equivalent to looping over some sort of iterator that'll submit many, many jobs for you. In addition, when you submit a job array, every element within that array, like every ordered list or array, it has an index. Same thing with these Slurm job arrays. Every element within that array has a unique identifier called its Slurm array task ID. The job number, suppose your job happens to be the 0th element of your array, starts at job number, what do we have here? 35416, right? what's being represented by 35416 underscore 3, that's actually actually, I don't remember. Are the elements, are they 0 offset, or do they start at 1?
Pretty sure it starts at 1.
Okay, starts at 1. Guess it's the sort
We're
of.
gonna find out in the exam.
Okay, yeah, right. So this would be the third element in the job array, whose first job is job ID 35,416. Yeah, actually, this is a pretty serious submit script. Okay, on slide number 16, we have a version of the next submit script that we want to run, but instead of typing this by hand, what you should do is go ahead and let's do cp/c1 workshops 2 job array submit script. Do we need to carry anything else?
No, because
Yeah, we're gonna, okay. So this is going to go back to our home directory. So everyone should execute this command. Get that job submit script into your home directory. And let's take a peek at what's going on inside this new submit script. This new submit script is called job_array_submit.sh. And let's take a look at what's going on in here. We've got some new features going on here, by the way. Notice that this shebang line is different than the previous one. We're using the bash interpreter here as opposed to the bourne interpreter. In the very first line, we're naming our job array. By the way, this could also, we also have shorthand for this. Oh, it's read only. Oh well. Here we're naming our job array. If you don't name your job, and you don't have to, this is an option. If you don't name your job will be assigned a name by Slurm. The name that Slurm will choose for your job is whatever the name of your submit script happens to be. So suppose we were to omit this line, the very first line. Our job would be named job_array_submit.sh. However, since we're naming our job, it's now going to be named array job. Not sure that's a whole lot better, but okay. Okay, I'm just picking on you. And we could even tag a job number into it if we wanted to.
Question?
Yes?
On that line, could I put a comment at the end?
Oh, you mean like this?
Yeah.
Good question. I don't know. I actually don't know. In fact, what I would do is I would probably put it in the previous line, but yeah.
Fantastic.
Yeah. So it works? Okay, great. The next two lines are our -O and our -E lines, but instead of using the %J for our job ID, what we're going to be using is %A and %A. So the %A is going to be interpolated with our array ID, and the %a is going to get interpolated by the index within that array. You'll see when we produce the output files and the error files. On the very next line, I use the -- array option, and and the range here is between 1 and 3, and I believe that's inclusive, so that should be 1, 2, 3.
Yeah.
And I believe the next 4 lines, that's old hat to us at this point, so everyone at this point should be caught up on what's going on in the next 4 lines. We're done with the SBatch directives. We move into the actual heart, or the meat of the script itself. I notice these next 2 lines, we're actually going to be we're making use of the environmental variables that Slurm makes available while our jobs are running or while our allocation is active, we're going to be printing out our slurm array job ID, and that's encoded in the environmental variable slurm underscore array underscore job ID, and we're also going to be printing out our task ID, which is encoded in slurm $slurm underscore array underscore task underscore ID. And the rest should basically be familiar to you from the last example, with one exception. Notice that instead of specifying the number of processes that I want to launch after the dash little n number, I'm using the variable for a slurm underscore array underscore task ID. So let's try to figure out what's going to happen here, right? What's going to happen is I'm using an array that has 3 elements. So that's actually going to launch 3 copies of this job. The first copy of this job, though, is going to have it'll be identical to the other copies. However, the first copy of this job, the slurm array task ID, is going to be 1. So the first of the 3 is going to launch with MPI run -n1 followed by Python and in the name of the script. So in this case, we're only going to launch 1 MPI process. We normally would never do something like this, but we're just illustrating the point. The second copy of this job in this array is going to be launched, but slurm array task ID is going to be 2, so we're going to invoke 2 Python processes for the second job in the array. For the third job in the array, that task ID is 3, so bless you, we'll be launching 3 instances. So what we should see is 3 jobs. The first job is run with 1 MPI process, the second job is run with 2 MPI processes, the third job is run with 3 MPI processes. So let's go ahead and give that guy a run. Oh, there's more?
Yeah, you need to edit that home.id.
Oh, yeah.
And that's going to be read-only for you in the C1 directory that you can save.
Oh, I didn't.
Are you at home? Where are you? Oh, you are. Why is it read-only?
Probably because it inherited the permission that it had in. Actually, I have no idea why it's not letting me edit it.
It's a job. It starts with a job.
There we go. Oh, because I was using view, not VI.
Oh.
It was actually doing what it's supposed to do. Let's give it a go. Hopefully it's going to run. I believe you.
Perfect.
Still waiting.
What are you writing the results out though? It's probably a range of something.
There it goes. There it is. Okay, so we have we ran our single job, our single array of 3 jobs. We're getting 3 error files and 3 output files. The error files are empty. That's good to know. So let's take a look at what's going on here. So let's look at so here's the output of our first element in our array. Remember, we were using the task ID or the array index to set the number of processes that we launch. Now, normally one wouldn't do this, but we're just doing this for pedagogical purposes. We're constructing the job this way. Our second job, we launched 2 processes. running on nodes 141, and our third job, the third element in our array, we've launched 3 processes running on nodes 103. So again, the takeaway here is job arrays are a simple shorthand way for launching multiple jobs using the same submit script, right? The same set of instructions, like one would do if you were doing it sort of the old-fashioned way by using some sort of for loop. You know, something sort of ugly looking like this that I've shown you here on the command line. I might embed something like that into my job script, but a more nuanced way to do that, and a slightly more elegant way, at least notationally, to do that is using job arrays. And again, it's important to remember, every job in that array gets the same set of instructions. How do we modulate what the different jobs do? We do that, like we did in our example, by using the task ID variable. So, questions? Preguntas? Marco, are we good back there? Okay, thumbs up.
My emails are getting through.
Excellent. Excellent.
Yeah, I'm getting quite a bit. If you've run a job and you were expecting an email and you didn't get it, check the email line in your submit script.
There's only one person who's doing.
Who?
No, I think it's everybody.
No, that's one. They put net ID GW.
No, because that's what was in the file that they copied. I said we're out of time.
All right, so that's good actually, because this is going to be part 2. We do now.
We never do reporting job errors. They're a bright group. They could probably figure it out from the slides.
It's okay.
We didn't have that much extra.
So that concludes that portion of the workshop, the Slurm portion. It looks like everything went according to plan, and we actually included a little bit more content than we got into this workshop, and I suppose we're going to figure out how to schedule the next one. But before we move on and sort of put a bow around this portion, were there any other questions about Slurm, about job arrays, about anything that we've talked about tonight, this evening? All right, okay. So, oh yes, we have a question.
So, I know we include a line for module load, but we don't include a line for module unload. Is that okay?
Oh, yeah, that's fine, because once your job allocation is relinquished, once it terminates, your environment is just squashed. It's gone,
Okay.
so you don't need to unload it. Yeah, you could, but you don't have to. We'll take care of that for you. The schedule will take care of that for you.
Okay.
Yeah. Okay, so reporting errors, when issues come up, you can email us at hpchelp@gwu.edu, right? This email gets distributed to all of us, to Marco, to Terrence, to Joe, Monica?
Yeah, but
I don't think you get it. Okay, but you're lucky actually.
Yeah.
You don't want to
That's
do
okay,
this.
yeah, I don't need it.
But that goes to every one of us, and oftentimes you may start working with somebody. Let's say maybe you're working with Jason, and you want to email him directly. I mean that's fine. You can do whatever you want, but it's probably more efficient. You'll get an answer faster if you email your issues to HPC Help, because all of us are going to be looking at it, and with more sets of eyes looking at your problem, the faster we're going to get a resolution to you. When you do send an email to HPC Help, help us help you. So a couple things here. Include the job number that you're referring to. That helps us zero in quickly to figure out what, from your job number we can see when the job ran, on what nodes was it running, and so forth. Please include your .err file, and I would even say include your .out file if it's not outrageously long, but at least include your .err file so that we can see the error message that you're seeing, if there is one. Include your submit script, or at least the locations, the path to your submit script, and the path to your .err file if you don't want to attach them to an email. And also include what modules you had loaded. If that's in your submit script, then that should be fine. We can figure out what's going on from just by looking at your submit script. One other thing here that's not written down, but from my personal preference, if it's a non-trivial issue that you're reporting, copying and pasting your errors is a lot better than a screenshot because I can copy and paste it, yeah, as opposed to looking at your screenshot and typing in everything you did. And it's just it's a little bit laborious to do that. So let's see. So, Jason?
Yes.
What's the plan here from this point?
It's all right though, because I mean we got the important stuff done. But the stuff
We crashed login 3 and login 4.
Yeah, I mean everybody has the tail end of the presentation, and honestly all we're doing for the next group of exercises is creating your own Python environment. It is incredibly easy. If you follow these steps, you can make your own Python environment. And the only thing we want to stress is this is useful for anybody who knows that they're going to want to install a lot of their own Python modules. Like we have standard builds of Python, multiple versions on Colonial 1, but if you know you're going to use obscure modules or you need to download like 100 different modules, build your own environment, because then you can run pip install and install whatever you want from the internet. You don't have to go through us. So that's my own Python environment.
And the same thing can be said for R?
Yeah, and same thing for R. If you want to install your own R modules, just follow these instructions. R is a little bit different because you actually run our build of R, but extra modules or libraries that you want to install get stored in your home directory, so you have permission from within R to install whatever modules you want. So if you know you're going to use R, just run through this exercise. You only have to configure it once, and once it's configured, you're good to go. And then the final section, honestly, is just a brief overview of Bash shell scripting. Most of you are probably already pretty well versed in it. If you are not, the exercises are up there. You can go through the slides, they're pretty easy. And it's a couple of simple scripts. Once again, if you have any questions about this, if you have follow-up questions, you can come see us. We are unfortunately not going to be able to schedule a third workshop. We just could not get classroom space this semester. But yeah, once we get to the end of shell scripting, that's it. That's the end of it. So, any questions? If there's anybody who like really needs a Python virtual environment, like right now, we can stay. It takes less than 5 minutes to set up. If not, have a good weekend. Yes?
This isn't a question, but the survey link that you sent out,
yeah.
When you go to fill it out, it allows us to edit the survey. Like,
yeah, I cannot figure out how to turn that off.
Okay.
Because they changed, it's a long story, but they changed global permissions on our enterprise G Suite. And I created that last year. You're actually looking at a copy of the survey I created last year, and I'm not allowed to edit the permissions. Okay. Please don't edit the survey. I'm aware of it. I couldn't figure out, I made a judgment call. And I know I probably didn't make the right one, but it's only going to people that registered for this class. So I'm hoping that, can you respond to it at all though?
That's what I can't figure out is like when I try to respond to it, it just tells me to edit it. Like,
all right.
So that's why I brought it up is.
Let me, I will try and fix it. If not, it's like a 3-question survey. And